A lot of people have requested me to show on how to analyze multi-location data or GxE data generated using Augmented Experimental Design, and that is they carried their experiments in different locations but employing an Augmented Experimental Design. I am going to use models, those linear models, to show you how to solve this problem. At the end of this, you will appreciate that how helpful models can be in solving problems, real life problems. Now, we expect in one location to have this kind of model here, in one location for Augmented Experimental Design. This Y model is just Y, and this mean plus the effect of block, effect of check, and the new genotype and error. Because in Augmented Design is that you plant genotype, and these genotypes are what we call new genotype, and in each block you insert checks, and these checks are replicated in every block. So we have these new genotypes and checks are called genotypes. Another model is this one, GxE model. That's Y is equals to mean, environmental effect, effect of block, effect of check, and effect of new genotype, and effect of genotype by environment interaction. This is an interaction term here. The rest are main effects. So that is it. So our interests are in this second model because we have to include the environment, and the experimental design is augmented design. Now let me import my data here, then we view this data. So we have how many locations are these? We have central, that's 1, eastern 2, then we have north 3, that's 3, then we have coast, that's 4. We have 4 locations, and in each location we have how many blocks? They are 5. You see up to number 5 here. Then we start a new location. So because we have 5 blocks and each block has 1 2 3 4 5, each blocks have 5 individuals, then the total number of genotypes we have is 5 times 5, that is 25. And on this 25 we're roughing this one is a check, and this one is a check, this one, and this one is a check. That means 3 times 5, those are 15. Of 25, 15 are checks. So that means we have only 10 new genotypes. We have 10 new genotypes and 3 checks. These checks, KEN, and this one are replicated in each block. So let's see how to do that. And another thing is that we are going to create new columns here, and the first column that we are going to create is this column that I have called a new check. New check is going to have 2 groups. One is the group with the new genotype, and another one is a group which has checks. So it's going to have a degree of freedom of 1. Shortly you're going to see how we do that. Okay, let's create a new column called a new check, and this new column is going to be created in this data frame which we have called it dots. Here dots, we create a new column here and we call it new check, and give everything in that column a value of 0. We do that, and let's open. You see we have this new check, everything is 0. Then we modify it that in this column called new check column. Scan this column called genotype. If you have a genotype, a value called KEN7, give it value 1. This is a check, and also this is a check, and also this is a check. So the R is going to scan through this, and if it finds checks here, it's going to give them a value of 1 here. So that's what this code does. So if we open again, we have new check column. It has zeros and 1. There are two groups. 1 is for checks, 0 is for the new genotypes. That's why this column is called new check. New genotype has a value of 0. 0, 0, 0, 0. Wherever there's 0, that's a new genotype. And wherever it's 1 is a check. Then we create another one. Before we do that, this code does the same thing like this. So you go and explore this code. I don't want to explain it because we have a lot of things. I consider this to be easier to understand than this for now, but you can use this one to do the same thing. Let's create another column that's called checks. Here I want to say that we are going to have our 3 checks and also a group which has the new genotypes. But now the new genotypes are going to be label 1 and the checks are going to have their names. So let's create a column called checks and give everything that column a value of 0. We do that. If you open here, checks here, everything is 0, down, everything is 0. Then we need to fit the names of checks. If this is a check, the name has to come here. This check, the name has to come here, and this check, the name has to come here. The rest would have 0. So we run that, this code, that's what it does. And then if we open, you'll note that we have the name of checks here. For example, let's look at this block 1, which is from here to here. Block 1 here to here. We have 1, 2, 3 checks and another group of 0. So we have a degree freedom of 3 because we have 4 individuals. This individual here, this one here, this one here, and this one here. Those are 3. Plus this 0, 0 is considered a group of same individuals. So the degree of freedom is 3 and the individuals are 4. So you see all the name of checks are written here, the name of checks, but number of the new genotypes is given 0. Now that done, we'll look at the structure, the column of location, column of genotype, and column of block. They should be factors. Also, column of new check and column of checks should be factors. So this column 1, column 2, column 3 should be factor. Column 5 and 6 should be factor. I'm using this function called labli. That's a base R function, and we are going to change these columns, column 1, 2, 3, 5, 6, into factor. I run that. Let's check that, see if everything is factors we wanted, apart from dry matter content, which is numerical. This is a response variable which is numerical. Thank you. Let's now fit our model. I'm going to use the generalized linear model that takes everything as fixed effects. So dry matter content is explained because we are going to look on GxE. Is explained by the location. We have a location here. All this, we want to include this location, block, new check. Remember new check has 2 groups, one of new genotype and another one of check, and also checks, and also effect of genotype, and also effect of genotype or by environment or location. This is an interaction, and we say our data is that. So this is the linear model. I'm going to use LM because I'm taking everything as a fixed effect. That's a generalized linear model. If I run that, then I want to see the ANOVA of this model. The ANOVA of this model, we do like that. So on the console, we have our ANOVA response is DMC. You can see the location is 3. We had 4 locations. The degree of freedom is 3. Blocks, we had 5 blocks. Is 4 here, degree of freedom. New check, these are those groups, 2 groups of new genotypes and check. They are, is 1. Checks is, we had 3 checks, so degree of freedom is 2. Genotype, the new genotypes, we had the new genotypes were 10. The new genotypes were 10. The degree of freedom is 9. The location and genotype interaction. Location, degree of freedom is 3 times genotype. Genotypes here means the new genotype, which were 10, plus the checks, which were 3. That was 13. 13 minus 1 is 12. Therefore, it's 12 times 3 to give us 36. So you can see now you have your effect of location. You can see your interaction here and the effect and the main effects here. So there was nothing which was significant here. And if you want to do your mean separation of this, you can use Agricola. You use Tukey HSD dot test. Then you put your model here, model 1, and genotype the group true console is true for us to print here. You can see everything, our genotypes are here, and there was no any significance difference. So that's why you see groups A. All things were the same. That's how we do. You can explore mixed linear model if you want. You can explore this if you want. You just copy and make some factors to be random. But now you have to use this package called LME4 or LML test for it to give you, instead of using LM, use LMER. Then some individuals, you make them to be random like this way. You whatever you want to make random. Now that genotypes are random, that means these ones also are random. Blocks are always fixed. Checks are always fixed. Checks are always fixed. Then you, after running that model, maybe you call it model 1. Then you do summary of model 1. Then also you want to see, if you want to see the blobs, you run mode 1. If you want to see, you can explore this on your own. These are analyzed data generated from Augmented Experimental Design, and also planted in different locations as a GxE. I hope this was helpful.